Okay, let's start our class. Yesterday we completed different types of protocols like RIP and protocol and enhancement of the Zero Gateway Routing protocols and the OSPF and ISIS and BGP. Two types of this routing protocols, and link state. Today we are going to learn regarding this uh, connected routes and static routes. Let's see this. What is the connected routes? From the graphics, from the picture, let's see here. We have two hosts. Host A and a host B. Intermediate device is the router in between this. And here we have IP address of this 192.168.0.0.0. This is the /24, and the next one is the 10.0.0.0/8 is the another IP address of this subnetwork host B subnet, and in the host A we have this 192.168.0.0/24. And this subnet device, subnetwork, connected to the interface of fast Ethernet 0/0, and host B connected to this fast Ethernet 0/1. So all these routing informations are added up in the routers in the routing table. For getting this one here, we have a command. We have a command to display the informations, route informations. See here. So IP routes. In this IP route, C means connected, S means static, and I means IGRP here, interior gateway routing protocols, and R means RIP, and M means mobile, and B by BGP, and all this labeling having this code. Okay. See here connected. This is the connected route. All these are the connected route. There is no static. There is no there is no RIP. There is no mobile. There is no BGP. There is no EIGRP. There is no OSPF. Okay. This C shows that the connected route only. Connected route. And 10.0.0.0.0/8 mean what? /8 means class A IP addressing. Okay, class A. If it is /24, this is class C. Why? What is the meaning of this /8 and /A? How it's come? This /8 /2/3/4 /255. How it's come this one? So let me try to explain it. This how it's come this /24/8. First, in the classes IP version 4, we have ABC. So this ABC is divided into this subnet. Okay, the three type of subnet. Then if it is class A, then what is the subnetwork of this? Any answer from your side? Can you answer? If it is class A, what is the subnet? Class A? Let me ask you a question. If it is class A, what is the subnet? Ropui, can you answer? Ropui, absent anymore. He is absent today. And Alvin? Alvin also absent today. Can you hear my voice?
Yes, sir.
Yes, sir.
Okay. Jonathan,
Yes, sir.
can you answer?
Yes. 255.0.0.0.
Okay, that's good. 255.0.0.0. That is the class A. That's good. This is the class A network. In the last class, I already explained about the classes of the IP address, like this class A is the 255.0.0.0 is the class A network, and also we are calling that this /8 network. Class B is the 255.255.0.0, and this is /16 network. And if this class C, then here 255.255.255.0, then this is /24. How come this /8 /16 /24, how it's come? This each and every octets of the classes having the number of 8-bit informations in a binary format. Each and every octet having 8-bit of data. So the first octet is having this 255 number, full bit. Okay, full bit. So we can say that this is 8-bit. That's why /8. If it is 255, then the summation of 8 plus 8 is equal to 24, and 255, this is called the summation of 4 times 8 is called this 24. That's why here we are having this /24, then here we are having this /8, and down here we have the interface first started 0/0, and here we have first started 0/1. This is the interface, the connection interface of this routers. So here, why this is /8 and this /16? In between this, there's lots of numbers are there, and here we have a /8. Before this /8, before this 8, we have 1, 2, 3, 4, 5, 6, 7 numbers, and between this 8 and the 16s, we have this 9, 10, 11, 12, 13, 14, 15. So what those things are there? We are not using, or we are using this number? Yes, we are using this number. 1, 2, 3, 4, 5, 6, all these numbers are using what? Using this CIDR. This is the classless interdomain routings. Okay. Interdomain sorry, inter classless interdomain routing. Okay, this CIDR, this is CIDR. Okay, this is using this CIDR, we can. Oh, sorry. Okay, anyway. Okay, using this CIDR, classless interdomain routings, that we can use different types of this slash network. There is no class A, B, C in this CIDR. In CIDR, there is no class. There is no class A, there is no class B, there is no class C. Based on this subnetwork, we can give the IP address. Let's see here. I'll show you the chart of this CIDR. Okay, here, let's see. The slash zero, in the slash zero here, let's see that this is the first one is the CIDR entry, and here we have a subnetwork, and this is total number of IP we can have, and usable IPs. Okay, this is the total number usable IPs and total number of IP and usable. This is subnetwork, and this is the CIDR slash. Here below this, let's see here, slash 0 is 00, all 0, and available IP address, and here available IP address, usable IP address here. So we can connect this type of this number of computers in this slash 0, and here in this slash 1. How come this slash 1? 128.0.0.0. How come this 128 in slash 1? How come this? In slash A, let's see here, in slash A, sorry, in slash 8, here this is 255.0.0.0/8. In this slash 1 network, we have this 128.0.0.0 is called slash 1. Anyone knows how it's become this 128? Why this is not 255? Why all these are 0 again? Anyone knows? Say no, ma'am. Answer, say no, ma'am.
No, sir.
Angela?
Yes, sir.
Can you answer?
No, sir.
Ruột pui here on chang thei mi lo microphone in ei lo o nghe internet a thalo sok o Alvin a khan chang thei em
mất rồi tweet thầy mấy đâu về sao
Along. Can you answer? Why this is 128 in
I don't know, sir.
You don't know? Teja.
Yes, sir.
Teja,
Sir.
can you answer my question? Why it is 28? Why it is 28? Why not 255 in this last one here? Did you follow my lecture?
Oh, sir, I don't know, sir.
Here, let's see. 128. How come this 128 in a binary? In a binary. What is the binary value of this 128? Anyone? Can you tell me? What is the binary value of this 128? If it is 255, then 1, 2, 3, 4, 5, 6, 7, 8, right? And if it is this 0, 1, 2, 3, 4, 5, 6, 7, 8, this is the binary value. And this is 1, 2, 3, 4, 5, 6, 7, 8. And this is 1, 2, 3, 4, 5, 6, 7, 8. Okay? This is the representation of this /8 in a binary format. /8 in a binary format. /8. Is it clear? Up to this?
Yes, sir.
Others? Other?
Yes, sir.
Yes, sir.
So say do here here na ngai ne heng ho hi on nakina munda ate if you working in another other organizations, then you are the MCA pass out, or maybe a MCA ex students, or maybe a dropout students, or maybe some people expected you to answer those things, simple, those network things, okay? So you have to answer it clearly. So what is a /8 and what is /1 and all these things? So you have to know this. This is the classless interdomain routing. Here, if it is 255, then all these are 1 and other is 0, 0, 0, 0. So if this is the classless CIDR in 1, this is a 1 to 8, 1 to 8, 0, 0, 0. This means that in binary number, we have a place value, right? We have a place value, right? Please answer, we have a place value or not? Please answer me. What is the place value of the first bit? Left, rightmost bit. What is the place value of the rightmost bit? One, right? 1, 2, 4, 8, 16, 32, 64, 1, 2, 8, right?
Yes, sir. Sir, binary yan yun. Abak 0 and all me. 1 mas saber niya. 1 to 8 binary.
1 to 8 niya nga chuchu abak hi 1 2 3 4 5 6 7 8. I don't inani. That's why this is 1/1, right? In the CIDR entry. slash 1. Is it clear my point?
Yes, sir.
Okay, here it's coming this slash 1. If this first octet least significant bit, the rightmost bit is 1 and others remaining 0, then this is called as slash 1. Okay, slash 1 network in the subnet marks. Okay, subnet marks, subnetwork. Do you get my point? Others?
Yes, sir.
Along? Do you get my point?
Yes, sir.
Other, it makes sense, this.
No, sir.
You don't understand? You don't
Yeah. Still confused.
still confused. See, in this class A network, I'll repeat. Adang khan tu ke khathiam lo rot pui te khain khathiam em like ka soi hi rot pui te. Ani hi aron ri chok thai lo reng reng. Zomon sangi i khathiam em
Yes, sir.
i khathiam mo.
Yes, sir.
Sir, a first bit ka I 9 is here ka 9 and 8 to lomi.
A first bit kulai 9 mo.
Ama saber 1 to 8 key, a binary key. 9 1000 key pakhat pa ingat.
Hey chuk kachut mani ka oh. So let me repeat again. If it is class A slash 8 network, if it is slash A network, class A network, this is the 255 ka englo direct ka rondu ta ka alvin attack group ho khan in lo ngai tha check de utak roi la hi in thm o ka hello in lo follow them alvin ta ka thm
follow the sir.
This is the binary number. If it is 1, 2, 3, 4, 5, 6, 7, 8, this is the binary 8 value. Okay, 8 value. This the first bit is 1, 2, 4, 8, 16, 32, 64, 1, 2, 8, 1, 2, 8. All this place value, all the place value of this binary number is 1. This is true. All this binary value is true. Then we have to sum up all the place value. Then it's come this 255. Then if it is 1, then this is over 128. This means that the first bit of this 7, 8, 9, 10. Okay. 1, 2, 3, 4, 5, 6, 7. Okay. So this is the first bit. The first bit is 128. Why? 1, 2, 8, 16, 32, 64, 1, 2, 8. Okay, that's one more bit. We have to do it. Okay. This the leftmost bit is 1 and others is 0. Then this is 1 to 8. Starting from here, if you count the value, how to count the value? This is the counting the value. This 1, 2, 4, 8, 16, 32, 64, 128. If you counting from the rightmost. We have to count it from the rightmost bit in a binary place value. Okay, this is the binary place value. This 1 2 4 8 16 32 64 1 2 8. So if you count it from here, you have to take out only the one decimal, one binary place value, or one binary place value only. So and so on. Let's see this slash 2 also. In the slash 2, this the first octet is 192. How come this 192? Then if you add it up here, one more bit here, in the slash 22, sorry, in the slash 2, then you have to sum up these two value. Okay, the last 2 bit we can see is counting from the leftmost bit. Okay, the first, we can say the first 2 bit from this counting from the left one. But binary, we have to count from the rightmost bit, like this 1 to 8. If you sum up this one, then here you'll get this 192. 192 in the slash 2 and so on. Is it clear right now?
Yes, sir.
Bidang khan khathiam lo ina ma'am. Others any questions or any doubt regarding this CIDR? This is the time to ask the questions. So here from 0 it's come up to this 32. Why not 33, 34, 35, 36? Why is not this continue this up to 32? Can you answer?
Because it is 32 bits.
Correct. IP version 4 is 32-bit addressing systems. Each and every octets contain 8-bit data. Then this is called this IP version 4 is the 32-bit addressing system. 32-bit addressing systems, and it cannot go beyond this. If it's go beyond this, then here the total number of IP will become 0. If you go beyond this 100, then 0 is up to 0. Okay, is sorry, minus. It goes to the minus size. Minus 1, minus 2, minus 3, minus 4. Minus is there is no value in the minus side. Okay. Okay. Can we? Okay, we can go to this slide. You can move forward to the slide. So here we have slash 24 and slash 8. I hope that you clear this. What is slash 8 and what is slash 24 and what is slash 16 and what is slash 4, slash 3, slash 2, all these things. And subnet directly connected to a router's interface and added to the router's routing tables. Interface has to have an IP address configured on both interface. Status and code must be in the up and up state. Routers so will be able to route all packets destined to all hosts in subnet directly connected to its active interface. So directly connected, connected routes means its interface has to have IP address. Interface means this interface. Okay, this connected, physically connected port needed to have an IP address configured, and both interface status code must be up and up state. Up and up means it's needed to connect, okay, to the subnet host. Okay, this is up and up state. Routers will be able to route all packet destined on all hosts in the subnet directly connected to its active interfaces. Consider the following example that using this picture, based on this picture, router has two active interface. This fast Ethernet 0/0 and fast Ethernet 0/1. Its interface have configured with the IP address, and it's currently it is up and up state, so that router add this subnet and its routing tables. So it's add in the routing tables, routing informations here. This 10.0.0/a is directly connected, is connected route. That's why it's directly connected to the fast Ethernet. That's all. It does not understand about the beyond the routing connections, beyond the hop counts, beyond the neighboring routers. It does not care about the neighboring routers, okay, adjacent routers. So it knows that this IP address 10.0.0 is connected in this fast Ethernet, this IP address. That's what. And in this next interface, 192.168.0.0.0/24 is directly connected to this, and the interface is the fast Ethernet 0/0. That's all. Knows by the routers in the connected routes. Okay, in the connected routes. Its interface has a configures with the IP address and is currently up and up stage, so the routers add those subnet in the routing table. So it's added up only in the routing tables. As you can see that from the output above, the routers have the directly connected routes to the subnet of 10.0.0.0/8 and 192.168.0.0/24. The character C, the character C is the routing table directly that the routes is directly connected routes. So as the name depicts that in the codes of this IP route, there are different types of codes, C, S, I, such and such, and up to this P. There are different types of these nomenclatures of this short form. So if you see, this is called this connected routes only. There is nothing other. There is no static route. There is no IGRP. There is no RIPA. There is no BGP. There is no EIGRP. There is no exterior gateway. There is no OSPF. All these things. If there are some EX or if there is some OSPF under this the routing tables, then this is configured using this open source spot first, or maybe in the routing information protocol RIP, or maybe in the interior gateway routing protocol IGRP, or extended interior gateway protocol, enhanced interior gateway routing protocol. So these characters depicts that what types of connections configure in the routers based on this command. So IP routes. Okay, let's see here in the static route. Apart from this connected routes, router A and router B, we are having this two routers, and we have a subnetwork, host A are there. So these two connected routes are having the problem, having the IP address in the IP address 192.168.0.0/24 and 10.10.10.0/24. So these two are connected together. Okay, connected together. There are some mistake in this router B and the host, and that's /24. This is some mistake here. This is the /8 network. This is mistake in this graphics. So here between this router and the B, the IP address is 192.168.0.0/24 and router B to host computer. Then this is called this 10.0.0.0/8 network. Okay, so by adding a static route, routers can learn routes to a remote network that is not directly connected to the to one of its interface. Static routes are configured manually by typing the global configuration modes. Global configuration mode, command IP routes, destination networks, subnet marks, next hop IP address. These types of configurations is usually used in a small network because of scalability reasons. You have to configure each route of each router. So simple examples will help you to understand the concept of these routes. So we have two routers connected together. In the previous example, in the connected routes, here we have only one intermediate routers. These two routers are interconnected together because of what? In the last class I already explained that if we have a different IP domain, different subnet, okay, different subnetwork. Here we have a subnetwork, different subnetwork. This is the class A network, and here we have a different subnetwork. This is the class C network. So these two, if you connect it through this switch or any other devices, then it cannot communicate in the class in the layer 2, data link layer. In the layer 2 it cannot communicate. So in the IP level also it cannot communicate without routers. So it's needed to route this IP address using the routers based on this the routing tables, based on the routing tables. So here we have the first subnetwork. This is a 192.168.0.0/0, and here we have 10.0.0.0. Here we have a different network. Same type here in the static route. Apart from this connected route, in the connected routes we can connect two subnet in the two subnet hosts in the router. But here in this static routes, router A and router B, we have a two number of routers, okay, neighboring routers, adjacent routers. So these two routers have a different subnet, okay, different subnetworks. This site also can have a host also, and these domains we can have 192.168.0.0/24 here, 10.0.0.0/8 network, okay. So these two are we can interconnected using this static route, and we can configure using the global configuration mode in this Cisco router iOS operating system. And then command IP routes, so we can do it destination networks, we can do the subnet masks, we can do the hop count IP address. These types of configurations usually used in the smaller network. We can fix the routing informations in this small network, not in a corporate, not in a big network, not in an enterprise network, but in the small networks we can do it by using this a small network, okay, this static route. And here let's move on to the next slide. A router is directly connected to the router because this is the explanation of this picture. Let me copy it here. Okay, router A is connected to router B. Router B is directly connected to the subnetwork of this 10.0.0.0 slash. Here also is mistake here. This is the slash 18 network. Since that subnet is not directly connected to the router A, the router does not know how to route packet destinations for this networks. However, we can configure that routers manually and router A. First, consider that the router A is the router A's routing tables before we added the static route. Before we added up the static route, now we'll use this static route commands to configure the router A to reach to this subnet of this slash 8 10.0.0.0.0. Okay. then the router must have the routes to reach the subnet of this area. Okay, to reach this host, then we need to update the information first. So these are the things in this the IP routes. In this static routes, we have to configure it here, okay, to reach these destinations. Okay, these are the routes, two different routes, connected routes and the static routes. Let's move on to the extended ping. Extended ping means I hope that you already understand about this ping command. Ping command is for checking this computer or the switches or any other routers that connected to the network or not, or this remote IP address is reachable or not using this ICMP command. Okay, Internet Control Message Protocol command. Then it's send out the ping request, ICMP request. Then if the ping request with the destination address, then if it's reachable to the destinations, then the destinations systems reply it back. It's reply the request, ping request, and from the source, and destinations reply back to the source. This is called the reply, ping reply, with the round trip times and the TTL everything's. Then it is reached back to the host senders. Okay. A ping command is the Cisco iOS operating system is used to test the accessibility of the device on the TCP/IP network. So ICMP is TCP/IP protocol. Cisco device also support these extended ping commands that allow you to perform more advanced checks of the host reachability and network connectivity. So the simple ping is for replying and those things for checking, and this one. But in the advanced ping, that there are some features to check the reachability and the connection performance and all these things. We can do it in the advanced ping command. With this command, you can define the source IP address or any IP address of the router's number and size of the ping packets, different timeout interval, etc. So we can edit up different types of features, source IP address and the IP address of the routers, and the number of ping packets, how many numbers needed to ping from the source to the destinations, and different types of timeout interval between this, etc. Then the extended ping command is invoked from the privilege exact command for typing a ping and by pressing enter, so it's executed. And then the extended ping is most often used to change the IP address and the ping echo packet, and considering the following example here is sending the ping request, then ping request replies from this router 1 to 2 and 2 to 1, and send the ping request, then router 1 reply to the router 2 this reply. Okay, it's replied back. Okay, this extended ping can have different types of controls. Number one is the protocols. Specify the protocols such as the Apple Talk or the CLNS, IPS, Novell, Opals, Vines. Also, there are different types of these protocols are there, so we can specify by using this protocol. Okay, so default is the IP protocol. So this is the TCP/IP protocol, this ICMP. But if we are using different types of protocol identifier, then we have to identify it inside this protocol. That's the first one. Number two is the target IP. So here, let's see. This is the source routers. Then this is the target router. Then if we want to ping from here to this, then we have to specify the target IP address of this, and repeat count. Repeat counts means specify number of ping packets which will be sent to the destinations by default 5 times. So how many times is send and reply the repeated times. Okay, ping packets. And number 4 is the datagram size. Datagram is the non-reliable communications in the TCP IP. So this is we can say this UDP also use a datagram protocol. So it send out this 100 bytes size of these datagrams. And the next point number 5 is the timeout in seconds. Specify the timeout interval. The default is the 2 seconds. The equals replies need to be received before the timeout expired in order to ping to be successful. So timeout is timeout in second is very important. This is the specified intervals. Okay, the default is 2 seconds. Within 2 seconds, if there is no reply, then the source destinations accepted as not disables. Okay, not disabled within the timeout period. If the destinations reply back the informations, then the source recognized as the timeout, it's expired. Okay. And point number 6. Point number 6 is the extended command. Specified whether or not a series of the additional commands will appear. The default is no. If you type yes, additional arguments will be shown. Okay, we can edit up the additional commands. Then the serial number 7 is the source address of interface. Specify the interface of the IP address of the routers to use as the source of the ping packet. So source address or interface. So we can specify the interface and the type of services. So in the IP address also we have a TOS in the IP headers. Okay, in the previous unit we already explained that the type of services. So we can specify the type of services. This is the internet services, quality selections. Then the default is 0. Then let's move on to the point number 9, set DF. Okay, this is the do not fragments bit in the IP headers. I think that you can recall the different types of the IP header fields. Okay, IP header fields. In this we have a fragment offset, the fragment bit, all these things, fragmentations also there. So this DF is bit is set, then this means that do not fragments. This packets. Okay, this frame cannot be fragment. Okay, in the networks. Validity reply data specifies whether or not to validate the reply data. The default is no. Data patterns. Specify the data patterns. Data patterns are used to troubleshoot a framing error or clogging problems or the serial lines. The default is this hexadecimal value 0x ABCD. This is the data patterns. What is the data patterns of this? Data pattern of this is the used to troubleshooting the frame, whether there is an error or not, clogging problems, synchronization clock problems, or in the serial lines. So this is the data pattern. And 12. Lost stick record timestamps verbose specified in the header options. All these things are specified in the header options. Lost sticks record timestamps and verbose, all these things. Sweep range of size. Specified the size of the ping echo perfect and that are sensed. This parameter is used to determine the minimum size and the MTU configures on the node along with the part of the destination address. The default is no. So sweep range of size is the sweeping the MTU maximum transfer unit. Okay, maximum transfer unit size between the routers. Okay, between the routers. So these are the different types of options in the extended command, extended ping command. So in the simple pings here, you can do it this simple ping in this router command, and here we can do this different types of this command. IP protocol target address, we can do it this we can use the default and the extended commands. Here it's type yes, then we give this type of services, all these things, and then here after entering those things, after giving the command of the extended, then here its success rate is 0%, 0/5. Some of from this area, then it not success to the, it doesn't reach to the destination successfully. So based on these informations, then we can have a different types of information. Okay, we can simply type ping, then here we have to give some extended informations, but here we can simply give the target IP address, target router IP address, then here you will get the success informations. Okay, we are type of a sequence to a board, then the sending is 5, and then the ICMP echo is timeout is 2, and then the success rate is 100%, 0 for the round tips average is this, the round tip clock speed of this round tip also very important in this for checking the internet connectivity. Here if I'm ping this google.com, so here we have a time, round trip time in this ping command. Time is 44 ms, 49 ms, 53 ms, and 57 ms milliseconds, and this is the TTL, time to live, that how long it can retain in the internet routings. 166 is the maximum ICMP packet. Maximum ICMP packet can retain in this routing, internet routing. Internet routings means in the router area. Okay. Then each and every routers, okay, reaching the routers, then it decreased by 1, this TTL. Okay, if it's reached this TTL, if it's reached the 0, this TTL, if this the decrease the each and every routers, even each and every hop count, then this TTL reach 0. Okay, this TTL reach 0, then router remove the ICMP packets. Okay, and this is the round trip time from my system to the Google server. This is the Google server IP address. Then from here it send out the packet. First it resolve this IP address to the DNS, Google DNS. Then Google DNS give back this Google server IP address. Then my computer send out this ICM packets to the destination IP address, and the bytes is 32 bytes, IP version 4, and it's replied back by the Google server, and the time taken by the ICM packet is 44 milliseconds, means from my system to the Google server, then this is 44 milliseconds. Okay, so these are the ping command in this. Here also we have a round trip time. Round trip time is this time. Okay. Okay, let's move on to this default routes. Okay, before moving to this default routes, okay, we'll leave it from this, next class we'll go into this default route. Now it's 11:15 afternoon. There no class for the practical afternoon. That's all for today. We'll continue in the next class, this one, default route. That's all for today. Let me call your roll number. Roll number 1.
Professor.
2. 3. 4.
Professor.
100.
Professor.
101.
Professor.
2.
Professor.
3.
Professor.
4.
Professor.
5.
Professor.
6.
Professor.
7. 8.
Professor.
9. 10.
Professor.
11.
Professor.
12.
Professor.
13.
Professor.
14.
Professor.
15.
Professor.
16.
Professor.
17.
Professor.
18.
Professor.
19. 20.
Professor.
21.
Yes, sir.
22.
Professor.
23.
Professor.
23.
Professor.
Hello, sir. Hello,
23.
sir.
Present, sir.
119 ka present. $109 po ka sa chatam. Present at trong sa Tailo niya.
24. Oh, hello. Oh, hello, 24, roll number 24. 25.
Present, sir.
Oh,
Sir.
okay, that's
Someone used such a 109 te chết ở hàng riêng non mệt.
Sir. Hello, sir.